So for this video, we are going to be doing predicting the products for the lab. So if you're having trouble with this section, this is the section, this is a video that you should be watching for that. So watch the video if you need help predicting products. If you don't need help predicting the products, then watch a different video for the part you need help on. Alright, so to predict the product, we're going to first figure out what is going to go on the other side of the arrow. So we have AGCL arrow. So we have two blank spaces, so we know since we have just one thing on this side, they're going to split up into two separate things. So it'll split up into AG and into CL. So those are our elements that they're going to split up into. Now we need to decide if there's any little numbers down here. So we know AG is a transition metal. That means it's not a diatomic molecule. So it's not going to have any little number down here. Cl, on the other hand, is a diatomic molecule. So it needs a little tiny number down here, a little 2 for the Cl. Alright, so these are the products for that first one. Watch another video if you're confused about how to balance them. Alright, now we're going to go down and do the next one. So this one, we're starting to get a transition metal right here, so it's going to make it a little bit harder to figure out what these products are. So we know we're going to start off with an Fe plus CuSO4. Some people keep thinking that this +2 charge means we need a 2 down here, but we don't. The +2 just tells us the charge of this. It doesn't tell us what number we need down there. Alright, so we have a CuSO4 and it's going to go to, so this one, we're going to have this one that's going to go and replace there. So we're going to get a Cu all by itself plus FeSO4. Now we need to decide if we need any little numbers down here. So the Cu doesn't need a number because it's not diatomic and it's by itself, so no number on the Cu. Now let's decide if we need a number on the FeSO4. So to do this, we look at the charges of each of them. So we have Fe and we have SO4. Now SO4's charge, if you look at the polyatomic ion sheet, or you can even just Google it, you see SO4 is -2. We're not sure what Fe's, what Fe's charge is on our periodic table. So what we have to do is we have to look at the problem and see they told us Fe is going to be a +2 charge. And so since these charges balance each other out, they are going to have a 1-to-1 ratio, and so this FeSO4 doesn't need any numbers by it. So this is your product. Alright, this one's a little bit harder down here. So stay with me. So we have Ki plus PbNO3 with a 2, and then it's going to go to this one. We're going to have the ones that are similar switch places with each other. So you're going to have now the K with the NO3 plus the Pb with the I. Now again, we need to figure out if we have little numbers down here. So how we do that, we look at the charges. So we have K. It has a +1 charge. You find that from your periodic table. You have NO3. NO3 on your polyatomic ion sheet is a -1. So these +1, -1 balance. We're good. We don't need any numbers down here. They just are left at 1 each. Alright, the next one we have, let me just erase this really fast. So the next thing we're going to have is we're going to have the Pb. We're not sure what its charge is on the periodic table. We have I, which has a -1 charge on your periodic table. So to figure out Pb's charge, we have to look at this problem over here. So this is the tricky part, so stay with me here. So we have Pb, not sure what its charge is. We have NO3, we know it has a -1 charge. We have to think, if we want this answer right here, PbNO3 we have to think what number would go there if we swapped and drop them would give us this answer. So we know the 1 goes with the Pb, and we see that right here there's a 1 there, right? No number means there's a 1, so the 1 goes with the Pb. Now I have to think, what number did the Pb give to the NO3? So we see that's a 2. So we know Pb, it's actually going to have a +2 charge. So that means over here it's going to be +2, and then we're going to swap and drop. And so we're actually going to have PbI2 for your answer. Alright, that's how you figure out those, and then you need to balance it. Alright, this one is kind of easy, even though it seems a little bit hard. But we're going to have C25H12 plus O2. It's going to go to something. We know the reaction type is combustion. So whenever you see a combustion reaction, you should be so happy because combustion reactions in the definition tell us what our products are. And our products are always going to be CO2 plus H2O. So that's how you know that these are your products, because I gave you the reaction type, so you could figure out those are your products. All right, last one. We have an Mg going with a HCl, so we're going to see the Mg and the H are going to switch places because they're both positive ions, both in group, both on the left side of your periodic table, things like that. So they're similar to each other. So you're going to have your H plus and then your MgCl. So now we need to figure out if there's any little numbers down here. We do that by looking first at this H. It's all by itself and it's diatomic. So we know that H, since it's all by itself and is diatomic, it's going to get a little 2. So next we need to look at Mg and Cl. We know Mg is a +2 charge from the periodic table. We know Cl has a -1 charge. Since these do not balance out, they need to swap and drop. So we get Mg with a 1 and then a Cl with a 2. Alright, like I said, you need to work on balancing these now, but those are your predicted products. Let me know if you have any questions.